radius of convergency and interval of convergency of a power series. Stay tuned, welcome and enjoy the class. And interval of convergency of a power series. So we shall start by knowing how to get the radius of convergency. Radius of convergency of a power series. In finding the radius of convergency of a power series, we are going to employ two methods. Method one, we shall use what we call the Cauchy's root test. And method two, we are going to use the ratio test. By formula of Cauchy's root test, we say R, which is equals to rho, is equals to what? R, which is equals to 1 over rho, is equals to limit as n tends to infinity of what? Of an 1 over power n. That is what? Rho. This formula will give us directly the radius of convergency of a power series. When we go to ratio test, we say R, which is equals to 1 over rho, is equals to limit as n tends to infinity of what? An over an plus 1. That will give us the radius of convergency of a power series. Let's use an example that will give us a distinct and detailed explanation of how we can find the radius of convergency of a power series. Example 1. You have been given a power series summation of an. Let's use summation of x squared all over m. So find the radius of convergency. In this problem, we are going, first thing is to identify which kind of method I am going to employ to find the radius of convergency. Now that this problem involves the denominator, the numerator and the denominator, we are going to use the ratio test. We are going to involve the use of ratio test, which implies that our R is equals to what? 1 over rho, which is equals to limit as n tends to infinity of an all over an plus 1. And we need to identify our an in that problem, which is 1 all over n factorial. And our an plus 1 is equals now 1 all over n plus 1 into bracket all over what? The factorial. Here, so our R will be 1 over rho, which is equals to limit as n tends to infinity of what? Our an. What is our an? Is 1 all over n factorial. We divide by our an plus 1, which is 1 all over n plus 1 into bracket over factorial. So our rho in this case is equals to 1 over rho. Our R is equals to 1 over rho, which is limit as n tends to infinity of 1 all over n factorial. We multiply by n plus 1 factorial all over 1 absolute. So we end up by saying R is equals to 1 over rho, which is equals to limit as n tends to infinity all over what? N plus 1 into bracket factorial over n factorial. Factorial cancels. Entry remains. This is like writing r is equals to 1 over rho as limit n tends to infinity of what? N over n plus 1 over n. Remember, n tends to infinity. Here we cancel and we say r is equals to 1 over rho, which is equals to limit as n tends to infinity of 1 plus 1 over n. This implies that our r, which is equals to 1 over rho, which is equals to limit as n tends to infinity, will be 1 absolute. What do we mean by 1 absolute? 1 absolute implies what? It is what? Negative. It can either be negative 1 or 1. It can either be negative 1 or 1. So we say our r is equals to what? Which is 1 over rho is equals to negative 1 or 1. So at this point, we need to identify whether the power series given is a diverging power series or a converging power series. Is a diverging power series. For converging power series, if you get L is less than 1, then if for converging power series, if L is less than 1, then we say the power series is what? Is convergent. And for divergent, if L is what? Greater than 1, this implies that the power series is what? Divergent. If L is greater than 1, then the power series is what? Divergent. And L to be greater than 1, we say any value greater than 1, which is 1 point something all the way to infinity, then the power series diverge. Now that we have gotten our R to be, it is exactly 1. It can be 1 absolute, which means it can be negative 1 or 1. Then we can conclude that our power series summation of what? Summation of x squared all over n factorial is a convergent. It's a convergent power series. Kindly, if you like my clips, stay tuned in all the days, subscribe, like, comment.